All right, these are the class notes for section 11. This is going to be the last section before the test starts. So this section is called System of Equations, and that means we're just going to be looking at two equations and see where's the value where they meet, or the values where they meet. Okay, so let's start here with an application. This is a reprint or a snippet from the New York Times, and it says, the movie The Interview generated roughly 15 million in online sales and rentals during its first 4 days of availability, Sony Pictures said. Sony did not say how much of that total represented the $6 digital rentals versus the $15 in sales. The studio said there were about 2 million transactions overall. So, the article ironically includes enough information to determine the number of digital sales and the number of digital rentals. As an important problem-solving strategy, we're going to begin by giving our variables names. So that's on any problem-solving strategy, that's always a really good place to start, is just deciding what everything equals, or what we can use to represent all the information. So they tell us here that we want to figure out our X is the number of millions of digital sales, and our Y is the number of millions of digital rentals. Okay, so there is a relationship between X and Y we are given. They tell us actually two relationships. The first one is that we know that the total number of transactions was 2 million overall. So let's look at that. We have our number of X's plus our number of Y's equal 2 million. And I'm using a 2 because they say millions is in the unit, so we don't need to put 2 million. We can just put 2. Okay, the other piece of information they tell us is that we have $15 million in online sales. So the total cost of the total amount we earned of X plus the total amount we earned from Y is equal to 15 million. So what that looks like here is, digital sales is our X, and our digital sales were $15. So we have 15 times our X is the amount of money we earn from our digital sales. And then we have our digital rentals, which is $6. So we have 6Y, and that is going to be equal to our 15 million. Okay, so that is the two relationships that we can find with that information. We will go over solving this in detail in the next pages in the section. But I am going to just show you a quick, let's see, what does it say? Determine how many digital rentals and the digital sales in the next two problems. So what we can do is we can solve it. And yeah, I will go into detail here. But I'm going to let that top equation equal 2 minus y. And I'm going to plug that in. So 15 times 2 minus y plus 6y equals 15. And I'm going to go through and solve this equation. So we've got 30 minus 15y plus 6y equals 15. I subtract that 30 over and add the y's. I get negative 9y equals negative 15. Divide both sides by negative 9. Here, and we get y equals, negative 15 divided by negative 9, we get roughly 1.67. And I'm going to round it there we go. That's a good enough rounding. So that's 1.67 million digital rentals. Now I solved for y first because that was the first part of the question. So 1.67 was our y, and rentals was our y. Okay, so there we go. Now, if we want to figure out what the digital cells were, we just use the equation. X equals 2 minus y. So x equals 2 minus 1.67, and that would be 0.33 million. So 0.33 million digital cells, and that kind of gives us both pieces. Now I know I went through that kind of fast, and you're more than welcome to pause it and stop it, but I'm going to go over how we actually solve each one of those soon. Okay, now before I do, let's look at the graph of this from the previous page. So here we have our graph, which is not the best graph, mainly because it doesn't cross at a very clean place, but I'm just going to get a good estimate. So we had these two equations. We had x plus y equals 2, and then 15x plus 6y equals 15. All right, when I try and get this graph, the y-intercept is 2, and I actually found this by finding the x-intercept, which was also 2, and I just graphed this line. If I go to graph the other line, I found my x-intercept at 1 and my y-intercept at 2.5. So if I graph those lines here, and I'm going to put my ruler about right there, and I'm going to get a rough graph. It's not perfect. I find that my two lines cross about right there, which is exactly where we found before. It's going to cross at about 1.67 at y and 0.33 for my x. Okay, so we just looked at a real-world application of a system of equations. And with this system of equations, it is essentially the place where two lines intersect. So before I go over how to solve system of equations, which is the main important part of this section, I want you to think about some special cases here. So there are 3 ways we're going to look at solving a system of equations. We're going to look at graphing, and that's the first way, and then we're going to look at substitution and elimination. My personal feeling is that graphing is a very nice way to see a visual connection to the skill, but it's the least accurate, and it also takes the longest. So we're going to look at graphing first just so we can kind of see the connection. I want you to think about 2 different linear functions. So there are 2 different functions. Which could be true? There's more than one possibility here. So either our graphs could intersect at one point, or the graphs could not intersect at all. Okay, the graphs can not ever intersect at more than one point, because if they are lines like that and they're 2 different lines, they're only going to ever intersect at one point, or they could be parallel lines and they don't intersect at all. The graphs don't intersect if their slopes are opposite reciprocals. Well, if you remember anything about opposite reciprocals, those are perpendicular lines. So that doesn't make sense. So either our graphs intersect at one point or they don't intersect, or this next question says, if I have these 2 functions, negative 3x plus 5 and 6x minus 10 over negative 2, and we want to find where these 2 functions are equal to each other, I'm I'm going to multiply both sides by -2 because I really don't like that fraction. So that gives me 6x plus, no it doesn't, 6x minus 10 equals 6x minus 10. And if I subtract the 6x over, I get -10 equals -10. So that's kind of interesting because those were the same line. There were infinite amount of points here. So that means here, 3 things can happen with our system of equations. And the best way to know those things is based off of what the graphs look like. The first thing that can happen is we can get one solution. Just like when we were solving equations, when we get one solution, it is a consistent equation or a consistent system. So I have here, when I have one line and another line, and they cross at exactly 1 point. That's what happens most of the time. We get one solution. Okay. We can also get a system of equations that has no solution. Okay, and when we get no solution, we call that inconsistent. It's an inconsistent equation. So that can happen every once in a while. And the third option that we have here is if we have one line and then we have another line that is the same line. And when that happens, we have infinite solutions. I cannot say all real numbers here. That is very important. It is not all real numbers because not every x value goes with every y value. So we say that there are infinite solutions, and then that means that this is the identity. Meaning one equation is the same as the other. It's like stolen its identity. They're the same. So those are the 3 possibilities of the types of equations we can get with a system of equations. Hopefully, those sound kind of familiar to you because it's a lot like when we solved a linear equation. We could get one solution, no solution, or infinite solutions, or all real numbers in that case. Okay, so let's look at how we solve these system of equations by graphing. Okay, once again, graphing is the least effective way to do this, so I'm just going to do these 2 problems. You can kind of get the idea here. So when I'm graphing, I think the easiest thing to do here is solve for y. And we've got our slope and our y-intercept. So on this first one, the y-intercept is 4, and our slope is rise 1, run 2. So I don't know if you can see the ruler as I'm putting it up here. It's kind of nice because it just helps me draw a nice straight line. All right, so there is that one. My other equation, I have this 8x minus 4y equals 8. So I'm going to add that 4y over to the other side and divide both sides by 4. We get 2x minus 2 equals y. So we have our slope and our y-intercept. So our slope is -2. And my slope is 2 over 1. So I'm going to rise 2, run 1. 1, 2, run 1. Rise 2, run 1. Now this is kind of tricky because my increments were going by 2, but it actually doesn't matter. As long as my increments are the same on each axis, I can rise and run the same even if it skips more than what we had. So I have here my equation, and I've plotted those points. Okay, this one is really nice because it goes right through exactly, and it's very obvious right there. So the point where these lines are crossing is the point 4, 6. Okay, I'm just looking, I go to the right 4, up 6. So that means a couple things. So the solution to this is the point 4, comma 6. That is one way to write the solution. The other way you may see the solution is you may see it written out as x is 4, y is 6. That's another way to write the solution. Okay? If this were a multiple choice question on the test, you would probably see the x value and the y value. Okay, because if we just give you a point, you can plug them in and it's very simple. But if we give you just the x value or the y value, then it's a little bit harder to know which one is what. So there you go. Graphing is really great in giving us a visual of what is happening. So let's look at one more graphing. I think the thing about graphing is you have to set these equations up so that they can be graphed. So I know I might do that kind of quick, and you can pause it and slow it down if you need to. But my first equation, I get 3/4 x minus 3 equals y. Okay, and then my second equation, I get, let's see, ooh, darn. Okay, let's add that 16 over. That equals 8y. And if I divide everything by 8, I get 3/4 x plus 2 equals y. So I'm going to graph each one of these. My first one starts at -3, which is in between the -2 and the -4. And I'm going to rise 3, run 4. So I'm going to rise 1, 2, 3, run 1, 2, 3, 4. And we've got our points here. There we go. And then the other one, the blue one, starts at +2, and that also rises 1, 2, 3, runs 1, 2, 3, 4. So we've got our line. There we go. Okay, those lines are special. They are parallel. And because they are parallel, we can visually see that there is no solution. There's no way that those two lines are ever going to cross, so there's no point where that happens, so there's no solution. Okay, that is all the graphing I'm going to do for these. In fact, I believe it's all that is in the notes. If you want to go back and do them, you can. If you want to try some homework ones at this point, you can. And if you're not sure about it, here's what you got to do. You need to solve for y to get the slope and the intercept, and then plot the points on the graph. Or graph it like we did the last section, and then you got it. You can do it. It's just graphing a line. Okay, this next section involves solving equations using substitution. Okay, this is a great way to solve an equation. It's a lot faster than graphing. So when we're solving an equation using substitution, the way to do it is you kind of solve for one of the variables. So if I were to take this equation right here, and it says that I have 3y equals -15x plus 18, and I just solve for y here, I get y equals -5x plus 6. All right, that is our y. And we also have a y up into the original equation. So what we can do is, if we know y plus 2x equals 5, we can plug that in right there. So we've got -5x plus 6 plus 2x equals our 5. And then we just get to solve a nice equation. Like that. I'm going to subtract the 6 over and divide both sides by -3. All right, so we get x is 1/3 here. There we go. And then the solution to a system of equations is not just one value, it's actually a point. So we have to find the x and the y value. So I go back over to what y equals, and I know that x is 1/3, so I just replace that out. So we get -5 times 1/3 plus 6 is equal to, let's see, that's -5/3 plus 6, which is 18/3. So -5/3 plus 18/3 is 13/3. So that's our y value. So our solution to this entire system of equations is the point x is 1/3, y is 13/3. Okay, so that means that when we're solving a system of equations by using the substitution method, we simply just need to solve one of the equations for one of the variables, plug that in, and solve. So let's look here, go through the steps. Step 1, I need to solve one equation for one variable. And it doesn't matter which equation or which variable you solve for. It's just one of the equations has to be solved for one of the variables. Okay, after we do that, step 2 is that we are going to plug the expression for the solved variable into the other equation. Okay, so whatever we solved for in the very first step, it's going to be an expression. We're going to plug that expression into the other equation. After we do that, we are going to solve that equation for the variable in it. Okay, there's only going to be one variable in my new equation, so I'm going to solve for that variable. And then I need to find the missing value or missing variable. Let's see. Variable by plugging step 3 into step 1. After we do that, we have our point and our x and y value completely solved for. So let's take a look at a problem here. Let's look at, whoops, there we go. 11.7. So this one is really nice. We have y equals -4x plus 8 and -x minus 2y. The reason this is nice is because one of our variables happens to already be solved for. I have y equals -4x plus 8. So I already know an expression that y can be equal to. Okay, so I know here that y is, oh my goodness, there we go. Y is negative 4x plus 8. So I'm going to put that right there in for y. So we have negative x minus 2 times ry, which is negative 4x plus 8, is equal to 12. So if I distribute that negative 2 through, I'm going to just solve an equation. Negative 12. I add the x's together, and I get 7x equals 28. And if we divide both sides by x, we get x equals 4. Now we're not done. We still have to figure out what y is. We know y is negative 4x plus 8. So if I go and I plug the value for x in to my original substituted equation, I get y equals negative 16 plus 8. So y equals negative 8. So we have our solution is x is 4, y is negative 8, but we like to write that as a point kind of just to show the connection between the two. And we've got our answer for negative 8. Okay, I just stopped and paused the video to photo math to make sure I did it right. So yay, we got it. That's always a nice little skill on these, is to, you can do that. But like on the test and on your homework, you need to show your work. So it's kind of nice to do that. It's nice to have the answer, but you do need to show how you got to that answer. Okay. 11.8 here. We have 2y equals negative 4x plus 8 and y plus 2x equals 5. So we can solve for either one of these. It doesn't matter which one. Just for the fun of it, we have this one. If I just subtract that 2x over, you got it. The other one, I could have divided both sides by 2. Doesn't matter which one you use, you're going to get the same answer. So I have 2y equals negative 4x plus 8. And now I know here that y is 5 minus 2x. So I'm going to go and replace that. So I've got 2 times my y, which is 5 minus 2x, equals negative 4x plus 8. And I have, after this, just a simple-ish linear equation that I can solve. So we got there. Oh, this is interesting. I'm just double checking to make sure I didn't make a mistake. Okay, yeah. If I'm going to add the 4x over to that right side, my x's actually cancel out. So I've got that. When my x's cancel out, and I need to check what kind of statement I have. So because that is false, we have no solution. If it was a true statement that was left, we would have infinite solutions. In this case, there is no solution. Okay, this last question here, I can either solve that first equation for x or the second equation for y. It doesn't really matter. So I'm going to take this first one, this x plus 2y equals 7. And I'm just going to subtract the 2y over. Like that. Now, I will replace my x into my other equation. If I replace it into the same equation, that won't work because things cancel each other out. So it has to go into the opposite equation. So I'm going to replace my second equation with the expression of x. So I have here 7 minus 2y is what x equals, so I'm going to put that in right here. So that is 7 minus 2y. And that all equals 5. So if we solve this equation for, now y is my only variable. Like that, we get negative 3y plus 14 equals 5. And I'm going to subtract the 14 over. That should be negative 9. Divide both sides by negative 3. I get here that y equals 3. Okay. Now, we just need to figure out what x is. We already have an expression for x, so we're going to plug that y in here. We know that y is 3. And if we go and we solve that, we get x is 7 minus 6, so x is 1. So our solution here is the point, x is 1, y is 3. Okay, so that is substitution. The whole point of substitution is we're taking an equation where we have the x and y related together, and we'll solve for one of those, put it into the other equation, and then that equation just has one variable, and then we solve it. Okay, let's move on to elimination. All right, the next method is called the addition method. Sometimes you'll hear it called the elimination method. So with substitution, because the two equations, we're trying to find where they are equal, and we can just take what one of the expression is for the other variable and substitute it in. With the addition method, because the two equations are equal, if we add them together, we eliminate one of the variables and we can solve for the variable that the one equation equals. So think about this question 1110. It says, let's add the two equations together. So if we take these two equations and add them together, x plus x is 2x. 3y minus 3y, those cancel out. And 7 plus 11 is 18. Okay, whoops, there we go. 2x equals 18. So now we have only one variable left. If we go and we take that equation that we're left with and we solve for the remaining variable by dividing both sides by 2, we get x equals 9. So we just found what x equals 9 really fast by just adding the two equations together and solving for x. If we wanted to, we could go back and find the y value. It doesn't ask us to do that, so I'm not going to quite do that yet. But I want you to think about what happened there. So when I added the two equations together, one variable eliminated. Okay, now they eliminated because the constants in front of them were the same, but opposite signs. Because when I add the two equations together and I had 3y plus negative 3y, those go away. So the addition method allows us to eliminate one of the variables just by adding the two equations together. Now the problem that we just saw here is a very simple case. I want to give you the step-by-step process for this. And along the lines of that, I'm going to do a problem as I give you the steps. Okay, so let's think of an example here from one of the next pages. So I'm going to do the problem C that's on the next page along with the steps. So as I go along the steps, I'm going to try this. Okay, so when I am doing the addition method, the first thing we want to do is we want to make sure that we line up the variables exactly like the problem is lined up. So the first step here, we are going to line up the x's, line up the y's, and line up the constants. Okay, so we want it to look, the equation to look like the equation we have here, where we have the x's lined up, the y's lined up, and then the constants. Okay, after we have that all lined up, step 2, I personally think is the hardest step, is we want to multiply 1 or both equations by a constant so that one variable has the same number but opposite signs as the coefficient. So there we go. So we want to multiply one or both equations by a constant so that one variable has the same number but opposite signs as the coefficient. I like to think of this as the LCM between one of the variables. So let's look at my equation over here. This 5x plus 4y minus 30. Okay. Oh, and then our other equation is 3x minus 9y equals negative 18. Okay, I want to find the LCM between either 4 and 9 or 5 and 3. We want them also to be opposite signs, so that is why I would pick my y value, because they are already opposite signs. So what I want to do is find the LCM between 4 and 9, which should be 36. So the LCM between 9 and 4 is 36. So what that means is I would take my top equation. I would multiply my equation by 9 because 4 times 9 is 36. So I would go 5 times 9 is 45x. 4y times 9 is 36y. Negative 30 times 9 is negative 270. My bottom equation, I would multiply that one by 4 because 4 times 9 is 36. So 3x times 4 is 12x. Negative 9y times 4 is negative 36y. And negative 18 times 4 is, 36, negative 72. I hope. All right, our y's are now officially the same. That's great. They are the opposite signs, but that's what we want. Okay, so step 3 is going to just have us add the two equations. And we're going to solve for the missing variable. Nope, sorry, not solve for the missing variable. Solve for the remaining variable. Okay, so let's look at that. So we have these two equations. If we add them together, we get 45x plus 12x is 57x. The y's cancel out. And then I have negative 270 plus negative 72. So that's negative 342. And I have the x, so I'm going to solve for that. I'm going to just divide both sides by 57. And we get x equals, I think it's probably 6. Negative 6. Okay, so there we go. We have the x solved for. The only thing that remains is this is a system of equations, which means we have an x solution and a y solution. So we have to do the last thing here, and that is step 4. We are going to find the remaining variable. So we're going to find the remaining variable by plugging step 3 into any previous equation with that variable. We can't plug it into, say, this equation because that equation doesn't have the y. But we can plug it into any of the ones that we started with. So let's just use, let's say I have this one, 5x plus 4y equals negative 30. That's one of my equations from the very beginning. If I plug my x value in there, here, we've got negative 30 plus 4y equals negative 30. That's not letting me write, sorry. Let me fix that. We've got, okay, negative 30 plus 4y equals negative 30. And I add the 30 over. I get 4y equals 0. Divide both sides by 4. And I get y equals 0. So the solution to my system of equations then is x is negative 6, y is 0. Or you can write it as a point, negative 6 comma 0. Either of those are perfectly fine ways to write the solution. Okay, let's try a couple problems. So this first one, I want to rewrite the problem so it's all lined up. Good thing is, it is already lined up, so I don't have to do that step. So what I'm going to do is I'm looking at my variables. Since my x have the same numbers but opposite signs, I'm going to get rid of my x. I can actually add this right now. And these problems are really easy when that's the case. All right, and then I divide both sides by 6, divide by 6. I get y equals negative 6. So I solve for my y. Now I just need to find my x. All right, I'm using this 4x plus 8y, 8y equals negative 24. If I plug in my negative 6 in, I get 4x minus 48 equals negative 24. I add the 48 over. And that tells us that we have 4x equals 24. And divide both sides by 4. And we get x equals 6. So our solution is the point 6 for x, negative 6 for y. That one was great because they were the same signs and you could just add them. And I think the same thing will happen with b. So if I look at these two, the y's are already the same but opposite sign. So we end up with 11x equals negative 11. Oh, I like this one. Divide both sides by 11. We get x equals -1. And here we get 8x plus y equals -16. Plug the -1 in. So we've got -8 plus y equals -16. Add the 8 over, and we get y equals -8. So our solution to this one would be the point -1, -8. And there we go. All right, we already did C on the last slide, but just a quick reminder, if you want to try it again without looking, you do have the solution -6, so you can check your answers there. And I'll give you a little secret. I did it on the last page, and then when I got to this page, I was like, I need to double check and make sure my answer was right in case I didn't mislead you guys. And I did. I used photomath and we had it. So I guess I need to trust myself. So okay, so let's go on to question D here. It says 5x plus y equals 9 and 2 times 5x plus 9 equals 7y. I really don't like that bottom equation. So what I'm going to do is I'm going to distribute that 2 through, and then I'm also going to switch my y and my 18, so I'm going to subtract that 7y over. So I end up with 10x minus 7y equals -18. So that's what happened with this bottom equation here. If I can get it, there we go. That bottom equation became this equation right here. All right, I'm going to set up now my system of equations. So I'm just going to write that 5x plus y equals 9 underneath my already altered equation. Okay, there are two equations. I see two possibilities of what we can do. I think that what I want to do is I want to multiply that bottom equation by 7. The other option is to multiply that bottom equation by -2. I don't know. I'm always more inclined to use bigger numbers instead of changing the signs. But you might be different. You might like working with a smaller number. I don't know. It's if you want to try the problem working by multiplying that bottom one by -2, I think that'd be a good experiment. You can kind of see if you get the same thing. Okay, so let's try this. We're going to go 10x minus 7y equals -18, and 35x plus 7y equals 63. Okay, so I'm going to add these two equations together. I get 45x. The y's cancel out. That's great. And then we have 45. Is 63 minus 18 45? Yes, it is. Okay. So now I'm just solving for x because x is all that is left in the equation. So we end up with x equals 1. And we're not quite done. There's one more thing. If we have our x, we need to figure out our y. We can use either equation we want to find our y. So I'm just going to use the one with the 5x plus y equals 9. And my x is 1. So I'm going to plug that in. And then subtract the 5 over. 9 minus 5 is 4. So we get the solution. X is 1, y is 4. The solutions are great written as points because you kind of see the relationship, and I like that. But if you like to see that you have the x is 1 and the y is 4, that is also a perfectly good way to write your solution. Okay, let's take a look at E here. So I have -3x plus 3y equals 4, and x minus y equals 3. I think I want to get rid of the y's. I think. We'll check. Or maybe it won't even matter. Who knows? So I'm going to multiply this top or the bottom equation by 3. And if I do that, my top equation is negative 3x plus 3y equals 4. And my bottom equation is 3x minus 3y equals 9. And the interesting thing happens here. I add the two equations together. I get my x's cancel, my y's cancel, and I end up with 11. 0, so everything that canceled is 0 equals 11. Well, I have no variables to solve for, so does the equation that they give me at the end become a true or a false statement? So because this is false, we have no solution. The cool thing about getting no solution is that you're done with the work. The sad thing about getting no solution is you did all of that work for nothing. So there we go. We've got a good example of when we can get no solution. The variables will just go away. And that's true if you're using substitution or if you're using elimination. All right, our last page here, 5x plus 4y equals negative 3, and 3x plus 6y equals 0. This is where if I were in class, I would ask you guys what you would want to do. For me personally, I think 5 and 3s are a little bit easier numbers to work with than 4s and 6s. But with the 4 and 6, the least common multiple is smaller. So it's really up to you. There's plus and minuses of each. I'll get rid of the x's. If you wanted to try and do the y's, you could. The thing about this one, I have 5 and 3. I'm looking for the LCM between 5 and 3. It would definitely be 15. Okay, so 5 times 3 is 15, and 3 times 5 is 15. Now the problem with this is we need to do one of them as a negative, because that is how we get them to cancel out. So I'm going to multiply through my numbers. I've got 15x plus 12y equals negative 9, and negative 15x minus 30y equals 0. Darn it. I'm just realizing if we would have gotten rid of the y's, the problem would have been a little bit easier, but that's okay. Let's just see what happens. We're going to go 0, and then 12 minus 30 is negative 18y equals negative 9, and I divide both sides by negative 18 to solve for my y. I get y equals 1/2. That's okay. Working with fractions is not a big deal in these problems. So we have our y. We don't know our x, but we do know our y. So I'm going to use one of the equations. I think I'll use the equation that has the 0 in it. So we've got 3x plus 6 times 1/2 equals 0. 6 times 1/2 is 3. So I'm going to subtract the 3 over and divide both sides by 3. We get x is negative 1. So our solution to this problem is negative 1/1/2. So if you would have done it the other way, you would have just gotten your x value and then had to solve for the y value. All right, so I just photo math checked it and we are good. These are really good problems to check using photo math because it will even kind of show you the steps. They may use, it looks like they're using substitution. They didn't do matrices, so that's good. So yeah, just check it. Now don't rely on it because that's not going to help you for the test or even understanding, but it is a really good tool to help you have some scaffolding. There we go. All right, let's look at G. We have our last problem here. I'm going to take that. Oh, we're going to have to multiply multiple things here. So I'm going to multiply this top one by 5 and this bottom one by 2 to get my x's to go away. I just saw that one right away, so that's why I went with it. But let's see what happens. So that's negative 10x minus, oh, sorry, that's supposed to be y. Minus 40y equals negative 30. Everything cancels out on the right side, but everything cancels out on the left side. Flip those. Everything cancels out on the left, everything cancels out on the right. So this is a true statement. And because this is a true statement, our solution is that we have infinite solutions. And that is how we write our answer for now. You cannot write all real numbers for these solutions because not every x goes with every y. So there are infinite solutions, but each one of those solutions has a distinct x and y pair to it. So that's why we write infinite solutions. Okay, so pause the video whenever you need it. I hope it wasn't too rushed for you. If you do have any questions, text me. You guys got this. You guys are awesome in a smart class, so I know you can do it. So, okay, good luck, and make sure one more thing, you set up your test appointment. All right, well, have a good week.